Welcome back. We are starting volume today, and that wraps up this last unit, unit 11. I like volume a whole lot better than surface area, so yay, I'm excited here because it's quicker than a lot of the problems that we've been doing. Today we're looking specifically at prisms and cylinders. So let's jump in. Surface area, which is what we are fresh off of, that deals with the amount of visible space on an object. Volume, on the other hand, that deals with the amount of occupied space that an object takes up. A little shaky on the O there, no idea why. Now, the way that you write the units, and I don't know, that's kind of wordy, but to me, how I make sense of like the difference between area and surface area and volume, the way that we write the units, the labels, that helps me make a lot of sense of this. We're going to write volume as like meters cubed or inches cubed. Cubic units is what we call that. Area, surface area, that was always like meters squared, inches squared. So if you think about these like prisms down here, surface area, since we say like inches squared, meters squared, that's how many little like 1 by 1 squares can fit on this figure. On every surface, how many little 1 by 1 squares? Volume is cubes, so it's how many little 1 by 1 by 1 cubes can fit inside this figure. Okay, so it's like how much space does it take up, not just how many little squares fit on it. I don't know if that's helpful, but that's kind of the difference between surface area and volume, like what we're measuring here. Starting with prisms though, so let's look at that formula because there is a formula. And it's pretty basic for the most part, at least the way it looks. To find the volume of a prism, all you have to do is find the area of one base, and then you multiply that by the height of the prism. So your formula is just going to be big B, area of a base, times the height. Now, couple things to point out here. First is starred right here. Remember that in a prism, and prisms are annoying because the base can be a bunch of different types of shapes. It can be triangles, hexagons, octagons, trapezoids. We haven't seen one of those yet. But the bases are the two congruent parallel faces. Unless it's a rectangular prism, they are the faces that are not rectangles. Okay, so it's not just the bottom of it, it's the two parallel congruent faces. I'm also going to make two other notes here. Big B, finding big B, that's going to vary depending on what your prism looks like. And B, again, just stands for area of one base. So if your base is a triangle, you'll do half base times height. If it's a hexagon, you'll do 1/2 AP. So this big B, how you find that, it's going to vary depending on your prism. H, that is the height of the whole prism. And remember that the height is the piece that connects the bases. If you have a highlighter, it couldn't hurt to highlight this formula. I sadly don't have one with me at home. But maybe highlight that. That's the big formula for the front side, or for prisms, I should say. Let's do some examples. That's the best way to learn. So both of these are prisms, and I want to find the volume. So it's just big B times H. All right, big B. Let's do that in a different color here. That can be the tricky part. That's usually the tricky part. Maybe identifying the bases first is what you should do. So I look at this, the bases are the non-rectangular faces. So it's going to be these triangles. On the next one, let's just go ahead and look at that. It's the trapezoids on the end here, the non-rectangular faces. Maybe identify the bases first. Big B is the area of just one of those bases. This guy's a triangle. I know I do half base times height to find the area of a triangle. So it's a right triangle, which is nice. The base and the height are just the two that make the right angle. So 7 and 8. So that's not too bad. I can work that out pretty quickly here. Lovely glare. 28 is big B. So let's come back. Let's not do that. 28 is big B. Let's just jump straight to it. Sorry. Times the height. And remember the height, that's the piece that connects the bases. It's not the height of the triangular base. It's the height of the whole prism, which is this guy right here. That's the piece that connects your triangles. So to find the volume, I just do 28 times 13, and it's 364. There is no units on there, so I can just say units cubed. So 1 by 1 by 1 little cubes, there's 364 of them that could fit inside that prism. All right, on the next one, so I'm gonna find big B first. And this time my base is a trapezoid. I don't know if you guys remember this. I'll definitely have to like add these to board notes. Maybe note this if you're not in the classroom, but for this one, a trapezoid, this is the formula. It's been a while since we've done that. So it's half times the two bases added together times the height. So let's remind ourselves where all those pieces are. And I'm just looking at the trapezoid on the end. I'm not looking at the 3D prism right now. So the two bases, those are the pieces that are parallel. So 14, and 8. Those are my bases. The height, and I'm just talking about the trapezoid again. It's the height of the trapezoid. That's the perpendicular piece that connects the bases. That's 4. Sorry for the bad glare. So when I figure out big B here, I'm just going to type it in my calculator. That is 17.6. 44. Let's say, wait, where'd that come from? 44 is big B. So now I can bring that to my volume formula. Big B is 44, area of one of the trapezoidal bases. The height of the prism is the piece that connects the trapezoids. That's going to be this guy right here, 10. So 44 times 10, 440, and this would be centimeters cubed. All right, on the back here, we've got 2 more prisms, and then we look at cylinders. Those go pretty quick though, so yay. Number 3, this is a hexagonal prism. The bases are hexagons. Volume formula doesn't change. Just the area of one base times the height. Obviously, when we go to find big B on this one, this is always like everybody's favorite problem. We have to remember how to find the area of a hexagon. And they even tell me it's a regular hexagon. So to find big B here, I'm going to do half AP. It is the apothem that takes work. The perimeter, and when I do big B, I'm just looking at one base. I guess I should point out, these are the bases, the hexagons. Okay, so when I find the perimeter of just one of those hexagons, just 6 times 6 sides, so that's 36. It's the apothem that's going to give us some trouble, maybe. So there it is right there. We'll draw that triangle bigger. So that's the apothem. This would be half of a side, so that's 3. You've got to find that angle. To do that, remember, it's 360 divided by how many sides there are, and then you split that in half. So this is a 30, 60, 90 triangle. I would definitely use the shortcuts just because it's way easier, and they asked me to write it in simplest radical, so I have to use the shortcuts. If you forget, this is the short leg 3. Short times radical 3 equals long leg, which is the apothem. Short, radical 3. So the apothem is 3 radical 3. Now I can multiply this to get big B, the area of just one base, one hexagon. If you're wanting it in simplest radical form, today is obviously a struggle, people. It's a good day to make this video, sorry. I leave the radical 3 out and just multiply the other 3 numbers. So it's 54 radical 3. Oh, the end of the year is hard, huh? So big B is 54 radical 3 times the height, and it's the height of the whole prism. So that's the piece that connects the hexagonal bases, 15. Same deal, leave the radical 3 out. It's 810 radical 3. Doesn't say the units, so I'm just going to say units cubed. All right, on the last one, so this is actually a composite figure. Let's do blue. Because it's two shapes in one. And huge relief here, composite figures for volume are so much easier because you don't have to think about like what you can see. If the whole shape is there, you find the volume of the whole shape. If it's just half of it, you divide it by 2. So if you can't tell, this is a rectangular prism on the bottom here. Just a box. So I'm going to say rectangular prism. And then on the top, we'll do that guy in red. On the top, that's a triangular prism. That guy up there. So it's 2 prisms in one. The whole prism is there. So all I'm going to do is find the volume of the bottom, the volume of the top, and I'm going to add them together. So let's do the rectangular prism first on the bottom. So honestly, if it's just a box and every face is a rectangle, you just do like length times width times height. I'm sure you've like heard that before. Because you could just do like the area of the base. I could do the bottom as the base. So that'd be 8 times 5. And then the height would be the piece that connects the top and the bottom, which is just 6. So anytime it's a rectangular prism, this maybe like will flash you back to middle school, but it's like length times width times height. Okay, so pretty basic when it's just a box. Let's see. That would be 240. Now I'm going to find the triangular prism and then add them together. So for this guy, let's see, I need to find big B. So the bases are the triangles, non-rectangular faces. Let's see if I can decipher this. So when I find big B, I need to find the area of like just this guy. So I know that this side down here, that's 8. The height would be the piece if I go to like the angle across from it and drop in a height like straight up and down perpendicular to it. I can see that they're telling me that that's 4. So to find the area of this, I do 1/2 base times height. Your base and height have to make a right angle. So I do 1/2 times 4 times 8. 16 would be big B. Okay, when I go to find the volume, I have to do area of the base times the height of the prism. That's the piece that connects the triangles. So this guy here, which would be 5. So 16 times 5, that's 80. I want to add those two, and then I have my full volume. So 320 centimeters cubed. All right. Now, jumping down to cylinders, these are a lot more straightforward than prisms. Prisms vary because of that base. That base can just be constantly changing to a different shape, so it keeps you on your toes. But cylinders, remember, they're almost the same as prisms, except the difference is the base is not a polygon. It's not a triangle, hexagon, trapezoid, whatever. It's always a circle. Okay, your bases are always circles in a cylinder, so that makes the formula more consistent. But the concept is still the same. It's the area of the base times the height. Now, the base is always a circle. The area of a circle is always pi r squared times the height of the prism. All you need is the radius and the height, and you can calculate your volume. This one can weird people out. This is called an oblique cylinder. It's just slanted, but they still give you everything you need. So to calculate the volume here, the radius, hopefully you can see, is 5. The height, it's like the true height connecting the circles. It's got to be perpendicular. So that's why it's kind of like to the side of your cylinder. But it'd be 15. Don't let the slantedness fool you. It's just called oblique. All I want to do is multiply that, leave it in terms of pi, and I've got my answer. So go ahead and do that, fill in your volume, and we're calling it a day.